Dimensional constants. What is meant by the dimensional constant? Means which is the physical quantities are having the fixed value. So the quantities are having the fixed value, means like a constant values which are having those constant values are also having a dimensional formula. Is these quantities are some of the quantities as given. These quantities have fixed value and possess a dimensional formula. So that the gravitational constant is fixed for all the units. Whenever we use the gravitational constant, then the number will be same, and according to the universal gas constant also same, the Boltzmann constant value also same, Planck's constant, Stephan constants, means those are the constant values possessed by the physical quantity, but they are having the dimensional formula. That is about a dimensional constant. If in case dimensional variables means the physical quantities which are having the dimensional formula, but the value is variable, means if in case of the possessed dimensional formula but its variable, means if the velocity is having that meter per second is the unit, and those are having some dimensional formula also, but their value must maybe changes, their value will be variable, means value will be changes of velocity will be changes, density will change, and force also will change, like that some of the units, most of the units are having the quantities possess a dimensional formula, but have variable value. So these type of quantities are called as dimensional variables. So next one is the dimensionless constants. Dimensionless constants. What are the dimensionless constants? Means the physical quantities which do not have any dimensional formula, but they have fixed values, like pi value. We know that pi is equal to 22/7. We will measure, that is 3.14. Those are the fixed value, but the pi do not have any dimensional formula for that. So this type of constants is called as dimensionless constants, and as well as dimensionless variables also there. The physical quantities do not possess any dimensional formula, but have the variable value, like strain, coefficient of friction. They have some value, means in case of relative values. So that also they are having the specific value, but they don't have any dimensional formula. Those type of dimensional formulas, those type of physical quantities are called as dimensionless variables. And in case of phase angle and solid angle are the dimensionless quantities, but they possess unit. Phase angle and solid angle both are the dimensionless quantities, but those are physical quantities are having the units. There is no existence of without units if the quantities are possess dimensional formula. The type of physical quantities does not exist, which are the physical quantities having the dimensional formula without units. That type of physical quantities does not exist. So that's why these are about the dimension constants and dimension variables, dimensionless constants and dimensionless variables. And now we are going to know the principle of homogeneity of dimensions. What is meant by the principle of homogeneity of dimensions? Means this principle of homogeneity, according to this principle, same units can be added or equated or subtracted. So that is the principle of homogeneity. Means according to this principle, the physical quantities of same dimensions only can be added or subtracted or equated. For example, S is equal to half 80 square. Let's see how it will happen. So S means we know that is the displacement. Displacement is we will measure it in meters, that is equal to velocity meter per second, time second, plus half. This is the constant, we don't consider it one, and A means meter per second square, and T second square. Here second square get cancelled, second cancelled, the remaining term as 2 meters. Means these are the having the 2, 1 by 2 is there, by measuring that also we can get the same value. Totally we can get the value for that. So total displacement unit. So this type of, according to the homogeneity of dimensions, principle of homogeneity of dimensions, the same dimension, the physical quantities are having the same dimensions can be added, subtracted, and as well as they can be equated. So like this. So what is the uses of dimensional analysis? By using the dimensional analysis, what are the uses? To convert the units from one system to another system. from the systems, from a CGS system, SI system, we can convert the system from one system to the another system. And to verify the correctness of equations by connecting physical quantities like this, if we did that S is equal to ut plus half square, by connecting these equations we can verify the equations is correct or not. By using the dimensional analysis also we can verify the correctness of physical equations of connecting physical quantities, and to derive the relation between the physical quantities involved in a phenomenon like this type of phenomenons like velocity. If we find out the velocity v is equal to nu lambda or v is equal to root t by mu type of politicals in second year, we have that in the waves unit. So, to verify, to know the relation between the physical quantities, to derive the relations between the physical quantities by using that dimensional analysis also we can find it out. So, these are about the units and dimensions. Next, what are the limitations of, already we know, we studied about the uses of these are the uses of dimensional analysis. Now, we are going to see the what are the limitations of dimensional analysis. Limitations of dimensional analysis. We know that we already studied about the uses of dimensional analysis, means to know the correctness and to convert from one system to the another system of units, and as well as to correction the equation, correctness of equation we can find out the, and we can derive the equations between the two relation to some of the physical quantities having the units. So, then what are the limits we are going to know, the limitations of dimensional analysis. This method does not give information about the dimensionless constants. If the quantities does not have any dimensions, then how can it will be having the dimensional analysis? We can't give any dimensional analysis for the dimensionless constants. And the next one is this method limited to physical relations while are power functions only. Means whenever the physical quantities only the power functions only, whenever L power n, M power A, L power B and T power C, whenever the power function are there, then only that this method is limited for only while the power functions only. So, if there is any power functions, we can't analyze that physical quantities according to the dimensional method. And the next one is this method is not suitable for the relations which are involving exponential values and logarithmic values and trigonometric, means sine, cos, tan, these type of values which are having the functions. By using this dimensional analysis, we cannot, this method cannot derive the relations by using the exponential, logarithmic and trigonometric functions. In this, whenever these logarithmic, exponentials and trigonometric functions are involved in the relation, by using the dimensional analysis we cannot derive an equation between the relation between the two any physical quantities. The next one is this method is not suitable to derive relation when a physical quantity is depends on another physical quantity which are having the more than 3 physical quantities, means more than the 3 other physical quantities, means the method is not suitable to derive relation when a physical quantity depends on more than 3 other physical quantities. If the one physical quantity is depends on the more than 3 physical quantities, see, by using the dimensional analysis method we cannot express the physical quantity relation. The next one is if the RHS, we know that whenever the dimensional equation there that is S is equal to ut plus half at square in that relation, like this relation, if the RHS is a relation, the sum or difference of some terms, in this case of this is about the sum, this is about the sum or difference of some terms, that relation cannot be derived easily by using the dimensional analysis method. We need to do more work to derive the equations which are having the right side sum and difference of the two values. So, these are the limitations of dimensional analysis. The first one is it does not give information about the dimensionless quantities, and this method is limited to the physical relations which are having the power functions only, and this method is not suitable for the derived relations involving exponential, logarithmic, trigonometric functions, and this is not suitable for to derive the relation whenever the physical quantity is depends on more than the 3 another physical quantities, and if the RHS is of a relation between the relation is the sum or difference of some terms, that relation cannot be derived easily by using this method. These are the limitations of dimensional analysis, and this is about units and dimension, units and measurements and dimensions.